This video is on the topic of Group VII displacement reactions. The Group VII elements are more commonly known as the halogens, and you will have already learned about their physical properties, relative reactivities, as well as displacement reactions. A displacement reaction in terms of Group VII is where a more reactive halogen displaces a less reactive halogen from an aqueous solution of its halide. The reactivity decreases down the group. So fluorine is the most reactive halogen, and it can displace those below it. Remember that a halide is an ion with a charge of 1- and not a halogen. A halogen exists as a molecule. For example, a chlorine molecule has the formula Cl2. Let's look at the displacement reactions more closely. We can use solutions of potassium halides and the halogens to show how reactivity decreases down Group VII. If we add chlorine water to separate solutions of potassium bromide and potassium iodide, there are two separate reactions that take place. Remember that the halide salt solutions are colourless. When chlorine reacts with potassium bromide, the solution turns from colourless to an orange-yellow colour. The colour change indicates that bromine solution has been formed, so a displacement reaction has occurred. A similar reaction occurs with potassium iodide. The difference here is that iodide ions are displaced in solution and brown iodine is formed. If bromine is reacted with potassium chloride and iodide, only one reaction will take place. Bromine will only be able to displace iodine from the aqueous metal salt solution and not chlorine. The equation for this reaction will be potassium iodide plus bromine forms potassium bromide and iodine. Finally, if iodine is separately reacted with potassium chloride and potassium bromide, no reactions will occur. This is because iodine is not reactive enough to displace chlorine or bromine from the aqueous metal salt solution. Let's have a look at some worked examples. Here, you are asked to name the salt formed when aqueous chlorine is reacted with potassium bromide. First, think if there is a difference in reactivity between these two halogens. There is. Chlorine is more reactive than bromine, so the new salt formed will be potassium chloride. This scores 1 mark. In Part B, you are asked why this reaction can occur. We know that chlorine is more reactive than bromine, or we could say bromine is less reactive than chlorine. Either way, you must state the comparison by using phrases like less reactive than or more reactive than, and name both the elements or compounds to gain the mark. The next worked example is a little more tricky. You must make sure you learn the colours of bromine and iodine in aqueous solutions, as then you can easily answer this. Remember, when stating colour change, you say the colours before and after the reaction to gain the mark. The colours of the sodium and potassium halide solutions are colourless. For Part B, you need to write the symbol equation for this reaction and include the state symbols. The sodium ion has a charge of 1+, and the bromide and iodide ions both have a charge of 1-. This means the formulas will be NaBr and NaI. The halogen molecules have a formula of X2, where X can be Cl, Br, or I. Now we have the correct formulas, we can balance the equation. The number of sodium atoms are the same each side, but the bromine and iodine atoms are not the same. This is a step that students often miss, as they forget to add the 2 in front of both the halide salts. Now that we have 2 bromine and iodine atoms each side of the equation, you gain the second mark. None of the parts of this reaction are solids or gases, so the state symbols will not be S or G. You are told in Part A that both sodium bromide and the iodine are aqueous. Therefore, we can use aqueous for all state symbols to gain the third mark. The displacement reactions for the Group VII elements are shown in the following table. Don't forget to check out all our other fantastic revision resources here at Save My Exams.